very important topic, that is ketone bodies. Ketone bodies are of three types. Number 1, number 2 and number 3. Number 1 is acetone. Number 2 is acetate, and number 3rd one is beta hydroxy butyrate. So ketone bodies are of three types: acetone, acetoacetate and beta hydroxy butyrate. These ketone bodies are synthesized in the liver. Ketone bodies are synthesized in the liver. They are used in the extrahepatic tissue. They are used in the extrahepatic tissue. So liver is hepatic. They are synthesized in the liver, but they cannot be used in the liver. The synthesis of ketone bodies is called ketogenesis, and the breakdown of this ketone bodies is called ketolysis. The synthesis of the formation of the ketone bodies is called ketogenesis, and the breakdown of ketone bodies is called ketolysis. They are formed. When they are formed in conditions. They are formed in conditions when glucose cannot be used in the body, or is not available. So they are formed in conditions when glucose cannot be used or it is not available. So there are two states. Number 1, either it is diabetes mellitus, whenever the glucose is available but insulin is not available, so that glucose cannot be utilized. So this is diabetes mellitus. And number 2nd one is whenever there is no glucose is available, that is starvation. So ketone bodies are of three types: acetone, acetoacetate and beta hydroxybutyrate. It is synthesized in the liver in hepatic tissue. The synthesis of ketone bodies is called ketogenesis. They are split up in the extrahepatic tissue, and whenever they are split up, this is called ketolysis. It is formed in conditions whenever there is glucose is not available for the body, or glucose cannot be utilized. So these conditions are diabetes mellitus, and number 2nd one is starvation. And very important thing, it is formed from a very bigger molecule, from a very important molecule. The name of that molecule is acetyl-CoA. So acetyl-CoA is a very important precursor molecule from which all of the ketone bodies that is acetone, acetoacetate or beta hydroxybutyrate. From this acetyl-CoA, all of these ketone bodies are formed. This acetyl-CoA is formed from three very important areas. We all know whenever the glucose is breakdown, whenever there is splitting of the glucose molecule or glycolysis, their glycolysis will lead to this acetyl-CoA, and this is pyruvate. If you remember, whenever the glycolysis was entering this glycolysis was entering into Krebs cycles, this pyruvate is changing into acetyl-CoA. So acetyl-CoA is forming from pyruvate. Number second, this acetyl-CoA can be formed from another molecule, that is oxidation of fats. These oxidation of fats molecule can lead to the formation of acetyl-CoA. Number third one is certain amino acids like tyrosine, lysine or phenylalanine. So these are three molecules, these three amino acids, tyrosine, lysine or phenylalanine. These three, pyruvate, oxidation of fatty acids and amino acids, will lead to the formation of acetyl-CoA. This acetyl-CoA has two fates. It can do two types of things. Number one, either it can lead to the formation of ketone bodies, or it can lead to the Krebs cycle. So this was the general makeup about ketone bodies. We know by now the ketone bodies are of three types. They are formed and the process is called ketogenesis. They are breakdown and the breakdown is called ketolysis. Their formation is taking place in the liver and they are used in extrahepatic tissue. They cannot be utilized in the liver because of the absence of a single enzyme. That enzyme we will be discussing in ketolysis. They are formed from a very important molecule. The name of that molecule is acetyl-CoA, and we know this acetyl-CoA is formed in the body from three very important things. Either it can be formed from pyruvate, or it is formed from the oxidation of fats, or it is formed from the amino acids. And those amino acids can be tyrosine, lysine or phenylalanine. Now let me discuss another very important thing. We have already discussed that amino acids are of three types: acetone, acetoacetate and beta hydroxybutyrate. Acetone, this cannot be metabolized. This molecule cannot be metabolized, and this molecule it does not, beta hydroxybutyrate, it does not contain a keto group. It does not contain a keto group. So acetone cannot be metabolized. This beta hydroxybutyrate, it does not contain a keto group. So it means acetoacetate and beta hydroxybutyrate are those two ketone bodies which give you energy. When are they giving you energy? In two states, two very important states: either it is starvation or it is diabetes mellitus. Why is this acetone molecule cannot give you energy? Because it cannot be metabolized. So these two are called acetoacetate and beta hydroxybutyrate. These collectively are called true ketone bodies. These both are collectively called true ketone bodies. So let me write it. These both are called true ketone